just put 0, just in case if you're not given, it's 0.
Delta H superscript 0 calculations. The standard enthalpy change, delta H superscript 0, for a thermochemical reaction is the sum of the standard enthalpies of formation of the products minus the sum of the standard enthalpies of formation of the reactants. Mathematically, this is expressed as delta H superscript 0 equals summation delta HF superscript 0 products minus summation delta HF superscript 0 reactants. The thermo table lists the standard enthalpies of formation for a variety of compounds. Click on the thermo table to get the delta HF superscript 0 value for a compound. Example: consider the following reaction. Calculate delta H superscript 0 for this reaction. Based on your calculations, predict whether the reaction is exo or endothermic.
This is the delta formation of each of the products and reactants. So what you have to do is to look at this values. They are constant. They will be given to you in any question, so you don't have to memorize it. It's going to be given to you. All right. So these are the values for the delta formation of all those substances as we move along.
The delta HF superscript 0 values for NO gas equals 90.3 kilojoules per mole. H2O gas equals negative 241.8 kilojoules per mole. Summation delta HF superscript 0 products equals 4 times 90.3 kilojoules per mole plus 6 times negative 241.8 kilojoules per mole.
Now remember, this is a summation.
361.2 kilojoules.
Now remember, this is summation of the products minus reactants. So that means you look for 4 times the formation of the constant value given for this formation, NO, and 6 times this for water minus the summation of this. So that means you're going to add this together and then add this together and subtract the products minus reactants. That's what they're doing here.
Minus 1,450.8 kilojoules equals negative 1,089.6 kilojoules. The delta HF superscript 0 values for NH3 gas equals negative 45.9 kilojoules per mole. O2 gas equals 0 by definition. Summation delta HF superscript 0 reactants equals 4 times negative 45.9 kilojoules per mole equals negative 183.6 kilojoules. Delta H superscript 0.
Now remember, the delta H for oxygen is 0. That's why anything plus 0 is just the number. So that's why this is like that. Okay, reactants is just 4 times the value for ammonia.
Equals negative 906.0 kilojoules. The negative value indicates the reaction is exothermic. Example, the reaction enthalpy delta HF superscript 0 SO2 gas equals negative 296.8 kilojoules per mole. Calculate delta HF superscript 0 SO3 gas in kilojoules per mole. Summation delta HF superscript 0 products equals 2 times negative 296.8 kilojoules per mole plus 0 equals negative 593.6 kilojoules. Use this relation. Delta HF superscript 0 SO3 gas.
Right, remember we are looking for delta H formation of SO3. From this equation, that means this is the reactant. Looking for the delta H of formation of SO3. You are given delta H, which is this. So, delta H equals to summation of the products minus summation of the reactants. And you are given the values for the products. So you're looking for the reactants. So it's going to be like algebraic equation, which means you're going to have delta F as your subjects to get your answer.
Negative 792.0 kilojoules divided by 2 equals negative 396.0 kilojoules per mole.
Right, this is a very simple calculation. Take your time. The only problem you can have here is your negative signs. Remember, you have to be very careful when you are doing your negative. When you have double negative, it's going to be positive. Don't forget that, just in case you come across such a problem.
Example, consider the following reaction. Calculate the reaction enthalpy, delta H superscript 0, for this reaction.
Right, this is your thermal table. This is your thermal table, PCl3. Let me go down. Calculate the reaction enthalpy delta H, PCl3. Look for PCl3 on this table. PCl3. Oh, it's like PCl3 is not on the table. But we have P4 is 0, Cl2 is also 0. So, okay. So this value. Okay, PCl3 is negative 287.7.0. Of course, P4 is 0 and Cl2 is 0. So when you plug in those values, you should get
Equals
something like this. So this is what I was saying. We have negative and negative. So this is going to be, of course, going to be positive. Positive, because negative will become positive. Negative, positive 574.0 kilojoules.
incorrect. Try again. Equals
Let's say K kJ. Okay.
574.0 kilojoules. Example. The standard enthalpy of combustion of butane is given by the equation. Calculate delta HF superscript 0 C4H10 gas in kilojoules per mole. First, balance the reaction.
All right, balance the equation.
Delta H superscript 0 equals.
All right, so what to do is, because you have this, the coefficient is 2, so you have 2 moles, multiply the delta H by 2, and you get your answer there.
Summation delta HF superscript 0 products equals.
Okay, the products here is going to be, let's say that is 8 times the CO2 value plus 10 times the H2O value.
Summation delta HF superscript 0 products equals.
So this minus plus minus this to be negative, negative. So negative plus negative will be negative. That will be a long, big number, negative number. Remember the delta H is given here equals to the products minus twice, because your reactants we have 2C4H10 plus 13 oxygen. Of course, 13 oxygen is 0, so that will be just 0 plus 2 times that. All right, so you have the delta H is negative 5756 kilojoules equals to products minus the reactants, that is summation of products minus summation of reactants. And the reactant here is 13 oxygen is 0 times 13, which is 0, multiplied by 2, plus 2 twice to C4H10, and that is what we're looking for. So in this case, you divide both sides by 2. Of course, first of all, you transfer this, bring like times together. When this comes to this side, it becomes 250. Remember, this negative crosses to this side, becomes positive. So that will be 6006 minus 5756 will give you 250. All right. So you have negative 2 delta HFC4H10 equals to 250. Now, in order to get your C4H10, you divide both sides by negative 2. So when you divide this side by negative 2, divide this side by negative 2. Negative 2 will cancel negative 2. So negative 2 here, negative 2 into 250 will be negative 125. All right? That's how you got the 125 from.
The bond enthalpy is expressed by the symbol delta H. For example, H2 gas yields 2H gas. This means HH bond enthalpy is 436 kilojoules per mole. Click on Bond Enthalpies. You will observe a table consisting of bond enthalpies for a variety of single and multiple bonds.
Right, these are the bond energy enthalpies, that is the energy required to break the bond between bromine, hydrogen, bromine, carbon, so on and so forth. These are the values you need to use in these bond enthalpies.
From the values given in the table, one can conclude that A. Bond enthalpy is a positive quantity. B. The higher the bond enthalpy, the stronger the bond. C. The bond enthalpy for a double bond is less than 2 times the bond enthalpy for a single bond. For bond enthalpy calculations, delta H reaction equals summation delta H reactants minus summation delta H products. Summation delta H reactants.
Now, I want to emphasize here, this is very, very tricky. Okay, let it write this completely.
Minus summation delta H products.
Now, if you look at this, this is like the opposite of what we did in the enthalpies. Delta HF formation is summation of products minus summation of reactants. So don't get it twisted, don't get it confused. When it comes to bond energy, it is the reverse. It is reactants minus products. Summation of reactants enthalpy minus summation of products enthalpy. So most students get this confused because they are used to product minus reactant, product minus reactant. But in this case, when it comes to enthalpy, bond energy, it is not the same like the enthalpy changes. So please take note of that.
Example. Using the bond enthalpies table, calculate delta H for the following reaction. HH gas plus ClCl gas yields 2HCl gas.
All right, these are the values for the enthalpy for these reactions. HH, that means you look for HH. All right, ClCl, look for ClCl331, and so on and so forth.
Delta H reactants equals 436 kilojoules plus 243 kilojoules equals 679 kilojoules. Delta H products equals 2 mole times 431 kilojoules per mole equals 862 kilojoules. Delta H reaction equals negative 183 kilojoules. Example. Calculate delta H for the following reaction. Bond enthalpies can be obtained from the table.
All right, this is the breaking down of the bonds here. This is bond breaking, and this one will be for a bond formation. So remember, it's going to be reactants, summation of reactants enthalpy minus summation of products enthalpy. So you look for the CH, you have CH, you have Cl to Cl. Okay, if you look at the table here, you will get your values on this table. Do we have them here? Let me see. You have HCl, CCl, CCl, HCl, and you have the CH. So those are the values you're going to use.
Equals.
So this will give you the values. So for the reactants, you are going to have ClCl, which is 243, and then you have CH4. We have CH1, CH2, CH3, CH4. So we have 4 different CH. So that's going to be 4 times CH. All right, that's what you're going to do. You have 1, 2. Let me use you have 1, you have 2, you have 3, and you have 4. So it's going to be 4 times this. Because CH is 414 times 4. Plus the Cl is just 1 bond. So plus this one. That's what you're going to do. And when if you do that correctly, you are going to end up with
equals
1899 kilojoules. Then for the products, you are going to do the same thing. For the products, it's going to be, this is a HCl. HCl is just 1. So this is a HCl. Then you have CCl1. You have CH1, CH2, CH3. So you have 3 CH. So you have 3 CH for that. 3 CH plus 1 CCl, which is this, 1 CCl, and then plus HCl here. So the total is going to, once you do that correctly, you're going to get 2004. So once you do that, you now, the delta H for reaction is going to be negative 105. All right. So what to do is you'll subtract the reactants minus the products. This is summation for reactant, the summation for products. So 1899 minus 2004 is going to give you negative 105 kilojoules. So that means this reaction is exothermic reaction because it has a negative energy.
Energy can neither be destroyed nor created. It can only be transformed from one form to another. Or, energy is conserved. Energy is classified into 2 categories. 1. Q equals quantity of heat. 2. W equals work. Work includes all forms of energy except heat. Energy is expressed by the symbol E. Thus, the change in energy is expressed as delta E. Recall the definitions of system and surroundings. Hence, there is delta E system and delta E surroundings. According to the first law, delta E system equals negative delta E surroundings. The energy changes should always be considered from the system's viewpoint. Hence, delta E system equals Q plus W. This is the mathematical expression of the first law of thermodynamics. In using this expression, be very careful with the signs of Q and W. Remember, Q equals negative for an exothermic reaction. This means heat is evolved or released. Q equals positive for an endothermic reaction. This means heat is absorbed. W equals negative if work is done by the system. W equals positive if work is done on the system. In solving problems, identifying the correct sign for W could be very tricky. Example: calculate delta E for a gaseous reaction system in which 30 joules of heat is absorbed and 24 joules of expansion work is done. Q equals positive 30 joules, since heat is absorbed. W equals negative 24 joules. Expansion work is done by the system. Delta E system equals 6 joules. Example: calculate delta E for a gaseous reaction system in which 30 joules of heat evolves and 24 joules of work is done as the system contracts. Q equals negative 30 joules, since heat evolves. W equals positive 24 joules. Work is done on the system. Delta E system equals negative 6 joules. Example: calculate delta E when a gaseous system absorbs 1.8 joules of heat and has 1.3 joules of work done on it. Q equals W equals delta E system equals this means energy moves from the delta E system equals W equals Q equals
Work W with expansion or contraction. Typically, gases involved in a chemical reaction are either reactants or products or both. Consider an expansion work. For example, H2O liquid evaporates H2O gas. In this case, work is done by the system. Work W equals force F times distance D. Since this is expansion work, W equals negative F times D. Recall, pressure P equals force F divided by area A, or F equals P times A. Substitute here. W equals negative P times A times D. A times D equals change in volume, delta V. Delta V is almost close to V. Thus, W equals negative P times V. Since almost all gases behave ideally, they follow P times V equals N times R times T. Hence, W equals negative nRT. Here, N equals moles. R equals gas constant equals 8.31 joules per mole per Kelvin. T equals absolute temperature. Often this expression is written as W equals negative P delta V equals negative delta N sub G. Delta N sub G is the change in the number of moles of gas. RT. At constant volume, delta V equals 0. Hence, W equals 0. Recall the mathematical expression for the first law. Delta E equals Q plus W. At constant volume, delta E equals Q. Often this is expressed as delta E equals Q sub V. At constant pressure, recall the mathematical expression for the first law. Delta E equals Q plus W, or Q equals delta E minus W. Substituting for W, Q equals delta E plus delta N sub G RT. Often this is expressed as Q sub P equals delta E plus delta N sub G RT. Substituting for delta E, Q sub P equals Q sub V plus delta N sub G RT. Note, Q sub P equals delta H. Thus, delta H equals delta E plus delta N sub G R T. Example. Consider the decomposition of solid ammonium chloride. Calculate the difference between Q sub P and Q sub V for this reaction at 298.15 Kelvin. Rearrange this equation. Q sub P minus Q sub V equals delta N sub G R T. Delta N sub G equals coefficients of products for gases minus coefficient of reactants for gases equals 2 minus 0 equals 2. R equals 8.31 joules per mole per Kelvin. T equals 298.15 Kelvin. Q sub P minus Q sub V equals equals 4.96 times 10 to the power 3 joules. Example. Calculate the difference between Q sub P and Q sub V in kilojoules at 298.15 Kelvin for the following reaction. Rearrange this equation. Q sub P minus Q sub V equals delta N sub G R T. Delta N sub G equals coefficient of products for gases minus coefficient of reactants for gases.
Right, what is the coefficient of product for gases? Look for it. It should give you 2 and 3 for the reactants, 2 for the products. And delta Ng is going to be negative 1 mole. So when you subtract that, you get a negative 1. Your R is a constant. The temperature is given right there. So your QP minus QV equals to negative 1 times 8.31 times 298.15. And that will give you negative 2.48. So QP minus QV is going to equals to delta N GRT. Give you negative 248, which is what we got here. All right, this will be our interactive problems. Fortunately, it's multiple choices, so you can pause to see how far you can do them. I mean, how you can get the answers, to check the answers here. I'll move on to 2 or 3 questions, then you can pause the video at your own time to solve the problems. Just pause the video and solve the problems. All right, these are the 10 questions I'm going to stop. I'm going to stop here and I will reveal all the answers to you now. But make sure you pause the video and write down your answers before you check the final answer right now. Right, for the first question, that is the answer is C.
Equals M C delta T. Q equals 167 joules. M equals 15 grams. C is to be calculated. Delta T equals T final minus T initial equals 33.0 degrees Celsius minus 25.0 degrees Celsius equals 8.0 degrees Celsius. Rearrange this. C equals Q divided by M times delta T. C equals 1.39 joules per gram per degree Celsius. Use the relationship Q equals M C delta T. Q equals 313.5 joules. M equals 10 grams. C is to be calculated. Delta T equals T final minus T initial equals C M equals 0.896 joules per gram per degree Celsius. Use the relationship Q equals M C. Q equals C 21.4 degrees Celsius. T final is to be calculated. Rearrange this. T final equals Q divided by M times C plus T initial equals equals 1.39 degrees Celsius plus 21.4 degrees Celsius equals 22.8 degrees Celsius. The chemical formula of carbon disulfide is CS2. By definition, delta H formation under standard conditions of elements is 0. Hence, click delta H naught equals the sum of the heats of formation of the products minus the sum of the heats of formations of the reactants. The sum of the heats of formation of products equals 4 mole. Delta H naught cuprous oxide solid plus 0. Standard enthalpy of formation of cuprous oxide solid equals negative 166.2 kilojoules per mole. Given delta H naught equals negative 571.6 kilojoules. Delta H naught equals 571.6 kilojoules. Apply Rule 1. Divide this equation by 2. Delta H naught equals 285.8 kilojoules. Delta H naught equals the sum of the heats of formations of the products minus the sum of the heats of formation of the reactants, plus 2 equals 123.9 kilojoules.
Hg liquid plus 1/2 O2 gas gives HgO solid. Delta H equals negative 90.8 kilojoules. Moles of Hg equals 32.5 grams divided by 200.6 grams per mole equals 0.162 moles. Apply Rule 1. 0.162 moles times negative 90.8 kilojoules divided by 1 mole equals negative 14.7 kilojoules. Delta H naught equals the sum of the standard enthalpy of formation of the products minus the sum of the standard enthalpy of formation of the reactants.
All right, these are the 10 problems and their solutions and how to work them out. Take your time to go through them. It's going to be very helpful to you. But this brings us to the end of this thermochemistry section. This is the section part 3 of the thermochemistry. I decided to break it down into 3 sections so that you don't have too much hours to spend on the same topic, so that it doesn't become boring. So this one is pretty long, about 52 minutes long. It's because of the 10 questions that we'll have at the back. So please subscribe to the channel so that anytime I post a new video, you will be able to be notified, and then you can learn on your own pace. Thank you for watching. This is Mr. Akintokun signing off. See you again next time. Bye-bye.